All right, in this lesson, we're going to talk about special types of functions. In the first lesson, we talked about what a function is, and now we're going to talk about a specific type of function called a linear function. So the vocabulary we're going to be using is as follows. A linear equation is an equation whose graph is a straight line. So when you graph all of the solutions to that equation, all of the ordered pairs form a straight line. Same thing for a linear function. It's a function whose graph is a straight line. So a linear equation and a linear function are basically the same thing. We're going to be using a function table, and that's a table that's used to show the solutions of a function, or sometimes called a t-chart. And then we're also going to talk about things called the x-intercept and the y-intercept. Now, an x-intercept is the place where a graph crosses the x-axis, and a y-intercept is the place where the graph crosses the y-axis. So we're going to talk about a couple things with linear functions. We're going to talk about how to solve them or find solutions to them. And we're also going to talk about how to graph them on a coordinate plane. So a linear function has inputs and outputs that when you graph them will form a straight line. So how do you find solutions to a linear function? Well, step one, we need to choose input values or our x values to put into the function. Now you can choose any x values you want. And that's the nice thing about this, is you can choose whatever you want. And we like to choose at least 3 values. And the reason we choose at least 3 is to ensure that they are in a straight line. And 2, we're going to put the values into the function and to find the value of the output, or our y values. So then what we'll have is an input and an output. We'll have an x value and we'll have a y value, and that'll be an ordered pair. And then we're going to write these ordered pairs either in a list or we're going to write them in a table. So an important thing to note here is that solutions to a function are always 2 numbers. It's always an ordered pair. It's always an input and an output, unlike the solution to just equations from last chapter that just had 1 solution or 1 number. So here's an example. Let's find 4 solutions to this function y equals 7 times x. So the first thing we need to do is choose 4 input values, or 4 x values. And again, we can choose whatever numbers we want, but I'm going to get creative, and I'm going to pick 0, 1, 2, and 3. So then the next thing we need to do is plug those 4 values into the function to find what our output values are. So I'm going to put 0 into the function for x. So I have y equals 7 times 0, which is 0. So that gives me 0, 0 as an ordered pair. That is a solution to that function. Next, I'm going to put 1 into the function. 7 times 1, y equals 7. So that gives me 1, 7 as my input and output solutions to that function. Likewise, y equals 7 times 2, which is 14. So that gives me 2, 14 as a solution. And finally, I'm going to put 3 into this function and get 21, which gives me my last ordered pair, 3, 21. Now, obviously, these are not the only solutions to this function. We just need to pick a sample of them so we can get an idea of where these ordered pairs are on the coordinate grid. Now, you can also put these solutions in a table or a t-chart, and this is what it would look like if I just organized my inputs and outputs in a table. I would have 0, 0, 1, 7, 2, 14, and 3, 21. So 2 different ways to show the solutions to that function, either in a list of ordered pairs or in a function table or a t-chart. But always remember that a solution is 2 numbers. It's an input and an output. So let's take a look at some more functions, and let's find 4 solutions to each one of these functions just so we get the hang of it. Now I'm going to organize my solutions in a t-chart, because that just makes it a little more compact and a little easier to do. So the first thing I'm going to do is pick some inputs, and I'm going to pick 4 of them. And again, I'm going to stick with 0, 1, 2, and 3. Those are usually the easiest numbers to work with. And then I'm going to put these into the function one by one. So if I put 0 into this function, I get y equals 0 plus 2. So y equals 2. And if I put 1 into this function, y equals 1 plus 2, which is 3. And if I put 2 into the function, y equals 2 plus 2, which is 4. And if I put 3 into the function, I get y equals 3 plus 2, which is 5. So again, I can put these in a table, or I could have listed these as ordered pairs, and this is what that would look like as ordered pairs. So either way here, you can write these solutions, either in a table or as a list of ordered pairs. 1b, I'm going to find solutions to this function. And again, I'm going to pick 4 inputs, 0, 1, 2, and 3. And if I put 0 into this function, 3 times 0 is 0. 0 minus 1 is negative 1. 3 times 1 is 3. 3 minus 1 is 2. 3 times 2 is 6. 6 minus 1 is 5. And 3 times 3 is 9. And 9 minus 1 is 8. So again, these would be 0, negative 1, 1, 2, 2, 5, and 3, 8 as ordered pairs. Let's take a look at these last two functions and find solutions. So again, I'm going to pick 0, 1, 2, let me get some more paper here, 3 as my inputs. And if I put 0 into this function, I get negative 2 times 0 is 0, plus 5 is 5. If I put 1 into this function, negative 2 times 1 is negative 2. Negative 2 plus 5 is 3. And if I put 2 into this function, negative 2 times 2 is negative 4. Negative 4 plus 5 is 1. And if I put 3 into this function, negative 2 times 3 is negative 6. Negative 6 plus 5 is negative 1. So again, my solutions, 0, 5, 1, 3, 2, 1, and 3, negative 1. And lastly, this function, y equals negative 4x minus 6. Again, I'm going to find 4 solutions using 0, 1, 2, and 3. And if I put 0 into this function, negative 4 times 0 is 0. 0 minus 6 is negative 6. 1 times negative 4 is negative 4. Negative 4 minus 6 is negative 10. Negative 4 times 2 is negative 8. Negative 8 minus 6 is negative 14. And negative 4 times 3 is negative 12. Negative 12 minus 6 is negative 18. So my solutions are 0, negative 6, 1, negative 10, 2, negative 14, and 3, negative 18. Now again, these are just 4 solutions. There are literally an infinite number of solutions to this function, and we're only picking a few of them just so we can start to see where these solutions fall on the coordinate plane. So that's finding solutions to a function, really not much to that. So what we're also going to do is we're going to actually put these ordered pairs on a graph and see what it looks like. They should fall in a straight line because these are linear functions. So that's what we're going to do next, is we're going to talk about graphing a linear function. So when you graph a linear function, we are going to use a line to represent all the solutions of the function. So like I just said, there are an infinite number of solutions to every one of these functions. So we can't possibly draw all the dots on our graph. So we're just going to pick a handful of dots, and then we're going to draw a line connecting those dots to show that all the solutions fall on that line. So the steps to graph a linear function. The first step, again, is to find at least 2 solutions. 3 is better, but if we know it's linear, we only need 2, because that'll tell us where our line is. And then we're going to plot those ordered pairs on the coordinate grid. And then lastly, we're going to connect the ordered pairs with a straight line, and make sure you extend that line all the way across the entire grid to show that these solutions go on forever in both directions. So let's take a look at an example, and let's graph this function. So the first thing I want to do is find some solutions to this function, and then I'm going to plot them on the grid. So I'm going to make a t-chart, or a function table. And again, I'm going to put 0, 1, 2, and 3. I'm going to pick 4 solutions to this. Again, you only need 2, at least 2. 3 is better, and then 4 just for bonus. So if I put 0 into this function, 2 times 0 is 0. 0 plus 4 is 4. So that gives me a solution of 0, 4. So if I plot that on the grid, that would be 1, 2, 3, 4. Right here is one solution to that function. Now if I put 1 into this function, 2 times 1 is 2, plus 4 is 6. So that gives me a solution of 1, 6. and that would be here on the grid. So really that's all I need, but I'm just going to make sure that this is a straight line, so I'm going to do a couple more points. 2 times 2 is 4, 4 plus 4 is 8. So 2, 8 is located right here. So hopefully now you can start to see that these are in a straight line. And I'm just going to do the last one. 2 times 3 is 6. 6 plus 4 is 10. And that is located right here. So now it's pretty clear to see that this is a straight line. And it's important to note I can't stop here because these 4 dots are not the only 4 solutions to this function. There are solutions that go all the way along this line. So any point on this line will be a solution to the function. So I'm going to show that by actually just graphing a line. And a lot of students just like to connect the dots that they plotted right there. But really we need to extend this line all the way across the grid to show that these solutions actually go in both directions forever on that line. So any point on that line will be a solution to this function. So let's just test that. Let's look at one right here. This point is on the graph, and this is the point -1, 2. So is -1, 2 a solution to this function? Well, if I put -1 into this function, 2 times -1 is -2. -2 plus 4 is +2. So that's another solution. So you can see that it's not just the 4 solutions I got in my table, it's actually every ordered pair that is on this line that will be a solution. And we show that by drawing a nice line all the way across my grid. And my grid isn't big enough to cover all the possible solutions, but that line shows us where it's going. So that's one way to graph a function, is to just pick some inputs, evaluate them, find some solutions, at least 2 solutions, and then graph them. Another way to graph a function maybe quickly and easily is to use what we call the x and the y intercepts. Okay, it's where these where the graph or where the line will cross each axis, and these are sometimes preferred because they're easily found, because every point on the x-axis has a y value of 0. So everything on this blue axis will have a y value of 0. So y will be 0 in my function. Likewise, every point on the y-axis, or the red axis, will have an x value of 0. So x would be 0 in my function. So if I just use these 2 points, I can find my line rather quickly, because 0 is typically a pretty easy number to do calculations with. So let's go back to that original function that we graphed, and let's just try to find where this graph crosses each axis. So where is this graph going to cross the x-axis? Well, I know that y is going to be 0. So I'm going to put 0 into my function for y, and it would look like this. 0 equals 2x plus 4. So what value of x makes this true? Well, -4 would equal 2x, -2 equals x. So the solution to that equation is -2. So my x-intercept would be at -2. So if x is -2, y is 0. So that would be right here on my graph. So this is called the x-intercept. And I'm going to abbreviate that x-int. That is the x-intercept. So that's where the line is going to cross the x-axis. Now if I want to find out where it crosses the y-axis, I know that the x value is going to be 0. So I'm going to put 0 into my function for x. Y equals 2 times 0 plus 4. Well, 2 times 0 is 0. 0 plus 4 is 4. So y equals 4 when x is 0. So here is my y-intercept, 0, 4. And that is right here. And that is called our y-intercept. So I know that my graph is going to cross the axes at these 2 spots, and now I know where my line is. So now I can see where this line will be, and now I just have to draw a line through those 2 points. And there are all my solutions. So you'll notice it's the exact same line. If I jump back a couple slides, the exact same line we had here. So if you'll notice, here is that x-intercept, 0, 4, and here is that y-intercept, -2, 0. It's just two different solutions that we found that were maybe a little easier to find with the computation. So we get the same line. So sometimes using the x and the y-intercepts are a quick and easy way to graph a function. So let's try to graph these functions using the x and the y-intercept. So the first one I'm going to find is my x-intercept. And sometimes it's nice to remind yourself what that ordered pair is going to look like. Well, the x-intercept will have a y value that is 0. So it's going to be something 0. So I know that my y value is 0. So I put 0 into my function for y. 0 equals x minus 4. Well, that means x is 4. There's my x-intercept at 4, 0. So I plot that, 1, 2, 3, 4. Here is my x-intercept. I don't know what happened there. And to find my y-intercept, I know that's going to have an x value of 0. Sometimes it's easy to get confused on which one's going to be 0. But remember that an x-intercept has an x value and a y-intercept has a y value. The other ones are 0. So if x is 0 in this function, I'm going to replace x with 0. Y equals 0 minus 4. That gives me y equals -4. So here is where my line will cross the y-axis at 0, -4. And that's 1, 2, 3, 4 right here. And this is my y-intercept. So now I know my line goes through those 2 points. And I just have to draw my line all the way across. I was a little off on that, sorry. All the way across the grid. So any point on this line would be a solution, but we just found probably the 2 easier ones to find is when x is 0 and when y is 0. One more. X plus y equals 2. Let's find or graph this function using the x and the y-intercept. So again, to find my x-intercept, it's going to have an x value, and the y value is 0. I have to think about that from time to time too. So if my y value is 0, I have x plus 0 equals 2. Well, that means x equals 2. So my x-intercept is located at 2, 0. This function will cross the x-axis at 2, 0. There. And then to find my y-intercept, this is going to have an x value of 0, and it's going to have a y value. So I say, 0 plus y equals 2. That means y equals 2 when x is 0. So my y-intercept is at 0, 2, right here. So those are the 2 points that I need to find out where my line is. And then if I'm just careful enough, I can draw my line through my graph. Again, make sure that line extends all the way across your graph to show all the possible solutions. Now again, I can check if I wanted to check some other points on this line, like this point right here. This is the point 1, 1. Well, if I plug that into my function, 1 plus 1 equals 2. That is also a solution. If I wanted to check this point right here, which is 1, 2, 3, 3, -1, 3 plus -1 is 2. That is also a solution. So you'll know that every point on this line is a solution. We just found 2 of the easier ones. So finding solutions to functions, we're going to plug in whatever inputs we want and find the outputs to get our ordered pairs, and then graphing those ordered pairs. We can either find solutions and graph them, or we can find 2 special points called the x-intercept and the y-intercept to find our points on the graph to graph them.